Welcome to all. We are going to discuss about the topic non-concurrent coplanar forces. Introductions. Equilibrium of a system of particles. Let us consider a system of particles and study of the equilibrium of the system. This is necessary. A study of the equilibrium of particles. It is to make a study of equilibrium. More than one particles. The first instance, it is the contradictions. We shall take that the different particles of the system lie in the plane and the forces acting on them also lie in the same plane. This study will include inter alia, a study of the equilibrium of a book resting on a table and of a ladder resting in contact with the two planes, one horizontal floor and other than a vertical wall. For such a study, it is necessary to understand the following the terms. The first one is external and internal forces. We had earlier considered the case of a book resting on a table. The book is said to be pressed down on the table with a certain forces, and the table presses upon the book with an equal but opposite forces. When either the book or the table only is the considered, this forces is the considered an external force. But if the system is the considered is book and the table together, then these two forces are both exerted by the particle of the system and therefore is called the internal forces. Since they constitute equal and opposite forces, they constitute what are known as mutual action and reactions. This thus it is said to Thus, it is said to be that a forces acting on a particle of system is called the internal forces. When it is exerted, when it is by another particle of the system is called the external forces. When the forces is due not a particle of the system but to particle lying outside the system. In the Newton's third law, internal forces occur in pairs. Each pairs constituting equal and opposite forces but themselves are equivalent to zero. It's called the constitute a null vector. In the cases of the force acting on a particle, the point of application is known as namely the particle itself and all the forces have a common point of application. In the present case of forces acting on a system of particles, the lines of the action of the forces do not necessarily have a common point and a forces becomes specified only when the point of application of the forces is also given apart from the direction and magnitude. It was earlier that two equal forces point the same way are not equal, their lines of action are the same. In other words, forces is localized vector is called the line vectors. The next one is the moment of a forces. The moment of the force about the some given point. The moment m naught of a force vector F about the point O is defined by the vector of the product. Is then the moment of a force the value for m naught equal to r into F vectors. The r is the position vector of OP. R is the position vector of OP. With respect to O, for any point on the line of action of F. This moment is introduce the point P, they choose the line of the actions F. If the condition P dash of the point such that OP dash equal to R dash. R dash into F. The mu naught equal to R dash into F. The R dash into F, the value for R dash means is the OP dash into F vectors. The OP dash, the value for OP into PP dash. OP into PP dash into F vectors. The OP into PP dash into F vectors. The OP into multiplying the values OP into F into PP dash into F. The OP into F, the value for R is the positions. FPP dash into F, the value for F. The PP dash, since the condition for PP dash and F are this is called the collinear vectors. In the absolute values, the magnitude it is denoted by mu naught is modulus of F into modulus of rho vectors. That is mu naught equal to modulus of F vector modulus of F into modulus of rho. The mu naught is the momentum. Mu naught is also momentum. The rho is the perpendicular distance of O from the line of the representation of F. Thus, any forces F is the uniquely specified the additions. To F is the moment vector m naught above the point O. Given modulus of m naught together with the direction of F. F along the one of the two parallel tangent center, the circle center O and the radius. Therefore, rho equal to modulus of mu naught divided by modulus of F vector and the direction of mu naught. The particular tangent and along the tangent a length equal to modulus of F. Will the forces is the magnitude. An orthogonal is denoted by the O, along which the unit vectors I vector, J vector, K vectors. Therefore, R vector equal to Xi vector, Yj vector plus Zk vectors. R vector is the position vectors. The capital F vectors equal to the value for capital Xi vectors plus Yj vectors plus Zk vectors. F vector is the force. Therefore, the moment of force mu naught, the value for the mu naught vector equal to R vector into F vector. The R vector, the value for this. The F vector, the value for capital Xi vector plus Yj vector plus Zk vectors. Therefore, Yz minus is the matrices the value for Yz minus Zy into I vectors plus Zx in minus Xz is the J vectors. The K vector means the Xy minus Yx. That is a scalar result of this moment m naught. In any direction through the point O is the moment of the force above the directions. Hence, we have the term of the moment of the force above the line equal to mu naught into mu naught vector into I vectors. The mu naught vector into I vector equal to Yz minus Zy. Is the Yz minus Zy is the moment of F about the I axis. Yz minus Zy is called the I axis. Is the I moment of vector into I vector equal to Yz minus Zy. Moment of vector into J vector equal to Zx minus Xz. Moment of vector m naught into K vector equal to Xy minus Yx. More generally, if I dash is the unit vector along the any line through the point of O, which is F as the moment mu naught equal to R into F. Then the moment of about lines mu naught into I dash equal to R into F into I dash. The moment mu naught into I dash is the vanishes either way. Mu naught and I dash are orthogonal. That is, I dash and the direction of F are parallel. I dash intersection the line representation of F. This is the truth. That is our the second one is F itself is the vanishes. The moment of a forces about the point is the vectors. The moment of the force is the line is the only scalar. A distraction is made between the forces that give the anti-clockwise moment. Is the anti-clockwise moment is the consider the positive values, and the given the clockwise moments is the take the negative values. Therefore, a co-plus system of the force acting on a rigid body, one refers often the concept taking a moment of the forces about the point in the plan. This is actually moment about the line through the point and the perpendicular to the plane. Hence, is the only scalar. The next one is moment of a set of concurrent forces. Is the let F1, F2 up to etc. Fn be the set of the forces is the nth term of the forces is the concurrent. A positive vector which is the represent the positive vector of with respect to the origin O. The respect to the origin is O. Therefore, OA the concurrent forces is the OA equal to R vector R. The concurrent phases, the resultant is the denoted the symbol capital R equal to F1, F2, F3 up to etc. Fn. And the line of the action are necessarily the pass through the points of capital A. The line of the action are necessarily the pass through. Now the value of R vector equal to F1, F2, F3 up to etc. nth term Fn is the n forces is the concurrent. Therefore, R into small r into R vectors is the R into capital R of the value for F1, F2, F3, up to etc. Fn. R in the multiply the values R into F1 plus R into F2 up to etc. R into Fn. Is this the distributive law? Then the result R has the moment about the point is the O equal to the vector. Sum of the moment of the forces is the individual forces on the set. It is called the moment of a set of concurrent forces. Thank you to all.